using generative artificial intelligence.
Okay, good morning, everybody. Thank you very much for inviting me. I'm afraid I'm not a doctor. I'm a computer scientist. I'm a poor computer scientist. And why am I here then? Well, I worked across a number of fields, well, several fields in my life, and some of them are in medicine. And what I can probably provide to this audience is a kind of vantage point on the development of especially generative AI that comes from different fields. I worked in aerospace. I directed a research center on AI for defense and security funded by Counterterrorism UK when I was in the UK for 22 years. And I worked with cardiologists, I worked with neurologists and so on. So what is the lesson that I've learned and what is that I expect to happen over the next years with generative AI? And I will use computer science as a field of comparison, and you can make a comparison with your own field. So what is happening is that the kind of chatbots that you know, ChatGPT, are not what you think they are, probably. You generally think of something that you ask a question and you get an answer. We have also seen it in some of the talks today, programming by asking a question. That's really not what is happening nowadays. What is happening is that there is a continuum of development that has been mentioned at the end of the previous talk that is towards something far more complex. So the current status quo is kind of the chatbot, but what is happening increasingly is the knowledge co-pilot. That is the co-pilot that helps you do your own tasks. And I will mention a little bit about this. So something that is an assistant is always with you. But the next step is effectively the agentic scientist, the scientist that produces hypothesis and tries to verify the hypothesis. So let's go through them, and I will explain how this has happened in computer science and how it may happen to you. So we all know that science in general is multimodal and it's very complex. We tend to have information that definitely outpaces human understanding. At the moment in computer science, in artificial intelligence alone, there are at least say 5 or 6 papers that are published every day that are worth reading, and probably 6 or 7 a week that may change your point of view. So that's something that, I have a student who really wants to read them all and always says, well, I don't really know, when can I work? And that's quite important. And our papers are published, are finished today and published today. So you don't wait for the normal publication. It goes directly to an open resource. So you tend to have, of course, text, literature, protocol, clinical notes, images. You can have structured data, you have time series, and then here you probably have the multi-omics type of data. And these are very different data. These are not data that necessarily a chatbot will be able to understand or take in. And that's pretty much the same in many other fields, including computer science. And mostly what you tend to have is that these kind of resources, this kind of information is fragmented across both systems, because there are different databases, for example, but also they can be buried in unconnected modalities. And this makes very difficult to take it all in. So moving on from the chatbots, the next step in the continuum is effectively the evidence-grounded AI. What is the evidence-grounded AI? Well, we move from the creative answer that is given to you, given a prompt that can be wrong, can be probably, well, the system may hallucinate, as you say. That is not very different from asking a colleague in the tea room. You go there and say, oh, what do you think this could be? Oh, well, I think this is, are you sure? Oh, yes, of course. But how do you know? And this is exactly what happens with a chatbot. They will give you an answer based on something that they have learned somewhere with a statistical distribution, and they tend to be very convincing. But the next step is to say, well, show me the evidence. And this is the first step. The first step is what is called retrieval augmented generation or agentic AI using tools. Basically, what you are asking is, yes, give him your opinion, but the first thing that you give me is the evidence. So the system is able to go to a database of documents and retrieve the relevant documents and retrieve the snippets of documents that are relevant, read them, and then give you the answer. And when you ask, where did you get that? You get the answer. If you go to ChatGPT or Gemini, you start having that. Especially if you ask a question and say, well, show me the evidence of what you're saying, you will start receiving links. It's been happening quietly, but this is something that you definitely see. And in particular, you see it in computer science, when you ask a question about machine learning, for example. So this shows a little step that is extremely important. That is the fact that you can verify what is being said to you, which is obviously important. It's the equivalent to ask a colleague and says, and here is the paper, and look at on page 5. But of course, it's not just papers, it's databases. The following RAG, there was a retrieval augmented generation for documents. The following step has been using agentic AI for querying, for example, databases or APIs or whatever that is. Therefore, the system plans and tries to generate an answer from a system that is from something that is itself a system, more than one. So it gives you the fact that you can verify and you can check the provenance, because it may be true that someone says that, but you know, you're asking a question about astronomy and then the document was written by a flat earther. Well, you don't care about that. You don't want that. So you want to have provenance as well. But the following thing, when you have that, you may have a co-pilot. What is a co-pilot? A co-pilot is a high-speed research assistant. In many fields, for example, in law, what you will have is that, especially in the British law system, the Anglo-Saxon law system, not the Roman system you have in Italy, most of the judgment is based on precedent. So every time you have a case, you have to find all the precedents, all the things that happened before, the decisions were taken before, and this is done by an awful lot of people who tend to be young lawyers. Well, this is something that AI does very well. Finding data, finding relevant data, finding relevant cases. So what you have is that you can insert these tools into your workflow as part of the team. This becomes agentic AI. What is agentic AI? Well, basically, that means there is not one ChatGPT, as you have one engine that replies to you, but there are a number of them, each of them specialized, each of them able to access specific areas. So effectively, what you have is a team that knows your workflow and will provide the documentation, provide the information that you ask for at this stage. But what happens is that you can then embed intelligence in your workflow. So what happens is that you may have someone who doesn't necessarily need to know to receive a request. Someone who knows your workflow will know that because you're studying that case, tomorrow you will need this information, or in the future you will need this information, and this information is retrieved before you actually ask for it. Then you can specialize the request, you can ask for more, or you can say, no, this is not really what I want, but what you have effectively is a proactive assistant that is very different from the system where you sit, ask a query or prompt the system as it is said, and doesn't know anything about you, as it happens with a new chat in ChatGPT. So this is pretty much used in enterprise nowadays, this is what we are trying to introduce in enterprise nowadays. So it's something that is very close to a production level of AI. So what you really want to have is an assistant to a unified and contextualized knowledge, and you can provide access to that. That becomes distributed, that becomes scalable. You can have agents that access different types of databases and will integrate the information for you. Different types of data from the images to text, and you try to put the information together. And so this is far more than just a chatbot. This is a complete assistant. So the current benchmarks tend to be really challenging. This is in computer science, but basically what you have is that we have now testbeds that require the system to access something like 47,000 different databases. So better, these are APIs. Read it as a database. It doesn't matter what the source of information. And they tend to be very broad and at the same time very detailed, because in these 47,000, you have something like finance, weather, logistics, and what you have is an agent that first of all decides which area to go to, but then inside you may have still thousands of data sources, and still it finds the right one. It finds the right one at 75%. In 75% of the cases, will find the right answer. That's probably not good enough for medicine, but this is coming very close, obviously. So this is not a search tool anymore. So we moved from the chatbot to the search tool that will find the right snippet of text. This is something that looks for the answer, for an answer you have asked for. So you are still querying the system. And this is finding the right information, maybe in different data sets, and will provide the answer to you with evidence still. But then there is the next stage. And the next stage is where things become really, really interesting, because you start having scientific agents. So what is a scientific agent? Well, basically what happens is that these are systems that plan, that act and iterate over large periods of time. So you don't wait for seconds or minutes, as it has been so far. What you have, you give a precise question, and they will think for as long as it needs. It may be weeks, and then come up with not just the answer, but the hypothesis. This is true autonomy. It's the equivalent of asking a person, please do that and try to solve this specific problem. They will go out and look for the strategy to do it. This is very challenging. This is not something we have today ready for production. But this is really interesting, and this is what is coming. So if you can do that, what you have is that you have a system that works at some level in some specific areas or whatever, with some absolute limitations, but a superhuman scale, because it will be able to read the documents you can't read, not even if you're in a group, because it will be so fast. It's dangerous, yes, of course, it may be, but let's go on with that. So what you have is that, first of all, you have this multi-agentic capabilities, autonomous design potential that could even be connected to robotic execution. What you have is that the system can do the simulation for you and organize the simulation for you based on, obviously, on workflows that you have. We are not talking of just a system that invents. We are talking of rigidly regulated processes, exactly as you have to follow, that are given to the system, but then the system tries to do something different, think in a different way. This is an example I don't know anything about. I asked ChatGPT to generate it for me, okay? It may not make any sense at all. I don't have any semantics associated to that. But in computer science, this is happening. So this is a paper that came out in April, and this is a completely generated paper from the decision about what to explore, to doing the experiments, to finding the issues, correcting the issues, doing other experiments, and coming up with an idea that is verified and has been accepted. So there was no human intervention here. The only humans were the reviewers of the conference, of the workshops. And this is not a small thing. I mean, the idea it came up with is not only reasonable, but it was praised by the reviewers for the insightfulness. It was thinking differently, if you like. Of course, there were problems, by all means. It was the first one. But you understand that this is a point-to-point evolution. And this is really interesting or scary, according to what you think. So what are the challenges? Well, the challenges are, if you talk about life sciences, apologies for using this very broad term, is that the scientific data sets tend to be extremely heterogeneous, and it can be incompatible, it can be very difficult to connect. And we also have a lot of dynamic evolution. So the dynamic evolution means that if I receive 6 papers a day, I have to reorganize my knowledge based on those 6 papers and the rest. So I don't know how quickly your field evolves, but the more the field evolves, the more this is difficult to do, because systems tend to be, to have a rigidity that we don't want. And then we have, to some extent, to rethink the way we produce data. And this is something we have learned in computer science. You may think that writing papers is good. That's fine, absolutely fine. You may think that producing data that is queryable through a database is the right thing, but that's not available necessarily, not the best way to make it available to artificial intelligence. So there is a way to build the databases so that the next generation of scientific data infrastructure can interpret it. And this is rethinking the way we produce the data sets. Because if you think the data sets and the information we produce is produced in an extremely inefficient way, you have to read 20 pages to understand the paper, right? That's the thing. And yes, you have to read it. It's great, we do it, but they are coming too fast. So can you produce your data, including experimental data, in a way that is completely machine readable? Well, apparently yes. And this is exactly what happened in computer science. So what we had was that without knowing, for 20 years, we have created the material for computers to learn. So there was a site called the Stack Overflow where people used to go when there was a problem. I have this problem using this language, and it's a very detailed thing. I give you the snippet of text. Can you tell me what is wrong? Can you tell me how to do it? And blah, blah, blah. And other people used to answer that and to vote on the answers and to vote on the questions. Says, oh, this is a really good answer, good question. Oh, no, this is the wrong answer. Oh, this is the right answer. And you could simply go to that website, type the query, more or less understanding, you found the thing, and most of the time you found the solution. But boy, this is the best way of training an artificial intelligence. We didn't know at the time. So what is the point? The point is there were millions and millions of statements of problems with answers voted by experts. So the systems do not learn the details. So it doesn't matter if in Python 3.6 and nobody uses anymore, there was this problem. The system learns the method. And then we had GitHub and GitLabs that are public repositories of software that are highly commented. And again, this is a way to train machine learning. So what happens is that the work of software engineers have changed completely. We don't do the basic coding anymore. Honestly, coders are among in the Silicon Valley at the moment, are among the least occupied people. As in, if you go to see the statistics, they have 70% of them are out of work, and they're all young people with a degree, with an MSc degree, because they don't need them anymore. So what happens is that the low level of programming is disappearing, and we have a higher level. So it's great for us because we do interesting things. We do experiments, we build things. So there is something called vibe coding. That is not, I write a program as we saw, I write a prompt and it comes out a piece of software, and I don't know. You give the full specs as an expert software engineer, you will get the full code out of it in a few minutes and a few hours. So you don't need to do anything on that. And this may happen to you as well. It will be longer, it will be more complex, but it will come to you. So be prepared for that. Don't think, oh, generative AI is just writing a prompt. If you're writing a prompt, you're doing something wrong. Well, do it, but it's not what you should do in the medium term. Okay, thank you very much.
Thank you, Professor Celania. Our last speaker, Dr. Benaldi from the University of Florence. Advancing precision oncology through AI and